Hello children, today I am going to teach you a lesson in Form 5 Chemistry which is coming under first term. So let's learn about the rates of the reaction. At the very first, I would like to pay your attention on the learning objectives. So at the end of this lesson, you will learn experiments to investigate the effect of changes in the surface area of the solid, the concentration of a solution, and the temperature, and also the use of catalyst on the rate of the reaction. As well as you will understand the effect of change in the surface area of a solid, the concentration of a solution, the pressure of the gas, the temperature, and the use of catalyst on the rate of the reaction also. And also you will learn about the mentioned effects of changes on the rate of the reaction in terms of the particle collision theory. Okay, and you will get aware about the nature and functions of the catalyst on a rate of reaction, how these catalysts are going to contributing in the rate of reaction. Okay students, what do you know about the rate of reactions? Are different reactions taking place by different rates? Yes, some reactions can happen within a fractions of a second, like explosions. As well as some are there are some reactions which take many years to happen. That means very slow reactions. Okay, likewise whether we experience these kinds of reaction which happen at the higher rates or lower rates, we can define a rate of reaction as the speed at which the amount of reactants decreases or amount of products increases. Again I'll explain. The rate of reaction is the speed at which the amount of reactants decreases or the amount of products increases. You can explain or else you can define the rate of reaction either use of the amount of reactants decreases or else with the use of amount of product increases. Okay, so if we build up a equation to find out the rate of reaction, you can simply give it as you can simply find the rate of reaction as by dividing change in concentration or volume or mass by dividing time. Okay, so that means we can measure rate of reaction as a change in the concentration of reactants or products per unit time. Understand? Okay, let's learn about the rate of reaction by using a simple practical. So you can refer this practical in page number 228. This is an investigation of rate of reaction between marble chips and dilute hydrochloric acid. So here calcium carbonate mainly representing the marble chips, and when we react calcium carbonate with this dilute HCl acid, it produces calcium chloride, water, and carbon dioxide gas. Okay, so let's look at on the procedure of this practical one by one. As first, you have to use a measuring cylinder to measure 25 cubic centimeter of 2 mole cubic decimeter dilute hydrochloric acid. Here you have to measure into this measuring cylinder. Then after add 5 grams of large marble chips to the conical flask and place of cotton wool at the opening of the flask. The cotton wool is there to allow the carbon dioxide to escape during the reaction but to stop any acid splitting out. The marble in excess it will be left over when the acid is all used up. Then place everything on a balance and reset it to a 0. Then this is the most important step. When you add acid to the marble chips, and when you then you need to record the reading on the balance every 30 minutes. Okay, so as soon after adding HCl acid into the flask, the balance show a negative mass. That means balance showing you a negative reading. So what is the meaning? Why this negative reading is coming out? Do anyone have idea? Yes, because the mass always goes up. Mass always goes down because the carbon dioxide escape through the cotton wool. So that the reducing mass is showing in this screen as a negative reading. Understand? When you plot a graph of mass of carbon dioxide lost against time, you will get something similar to this. In this graph, the y-axis, it represents the mass of carbon dioxide produced in grams, and also x-axis represent the time, which is in minutes. Okay, so then we can calculate the average rate of the reaction during any time interval by using this equation. What is that? The rate is equal to the mass of carbon dioxide lost divided by time. Okay, earlier also I have explained this equation, this relationship. Then if we find the average rate of reaction in first minute, can you imagine how we are calculating that? Yes, we have to divide the mass of carbon dioxide lost in first minute by 1 minute, that means by time. So we will look at this is the first minute. It produced, actually it lost like around 4.47 like gram mass, right? So you have to divide 0.47 by 1 minute. So you will get answer as 0.47 gram per minute. So that is the average rate of reaction in first minute. Understand? Then average rate of reaction in second minute. That means within this second minute, what is the average rate of reaction? Here you can read the mass of carbon dioxide lost here. So that is equal to the 0.2. Then you have to divide 0.2 by 1. The answer will be 0.2 gram per minute. Then average rate of reaction over first 2 minutes. That means this 2 minutes. Then it is averagely 0.67 mass of carbon dioxide produced has to divide by the 2 minutes. Right? So answer will be 0.34 gram per minute. As we can conclude the reaction is fastest at the beginning and then slows down because all the hydrochloric acid has been used up. You can see that when the reaction at the beginning, reaction has a much steeper slope. That shows us that reaction is fastest at the beginning. When it is further moving, then it is slow down and it increase. It decrease the slope also. It decrease the gradient. Okay. In the previous practical activity, you have learned the way of investigating the rate of reaction, right? So we can explain the way of carrying out this reaction by practical collision theory. Okay, particle collision theory. So in particle collision theory, we are talking about the collisions of particle, how they come into a reaction, how they start in a reaction, likewise. So reaction can happen only when particles collide. First, to happen a reaction, particles needs to collide each other. Okay, so not all the collision continue into a reaction. To be a reaction, that means to be a successful reaction, those particles needs to collide with the sufficient amount of energy, or we call it as a activation energy. That means particles have to collide with minimum amount of energy called activation energy. If not, they are not reacting each other. Okay, they need to exceed this activation energy. So the collisions with the energy greater than or equal to the activation energy are known as the successful collisions. Okay, so only these successful collisions always run into a reaction. Understand? So these particles collide each other and then after they run into a successful collision if they only exceed the activation energy. Okay. Rate of the reaction can affect by several factors. Okay, we'll find out what are those factors. First one, surface area of reactants. Second one, concentrations of reactants. Then temperature of the reaction medium, pressure of the medium, and also presence of the catalyst. Then after we'll look at on these each factors and how they contribute to rate of reaction. Change in the surface area of reactants first. Okay, let's find out how change in the surface area of reactants affect to the rate. When the surface area of solid is much higher, that means when it is finely divided into smaller particles, the faster the reaction is. Because as we all learn, only particles on the surface are available for the collisions. Also, the frequency of successful collisions increases as the surface area of the solid increases. That means they have that kind of relationship. Okay. So, as you all can see in this picture, when it is a bigger particle, it given limited surface area for the collisions. But when we finally divided into small particle, it given more surface area for the collision. So, when we finally divided these large particles into smaller one, it increases the rate. Okay. So, we use in this theory and we mainly applies this theory on catalytic converters which is in the cars. Okay. Effect of surface area of reactants on the rate of reaction can shown as using a graph as follows. So here I have given a graph which shown effect of surface area of the reactants into their rate. Okay. So you can see that when we consider in the previous reaction, which is reaction between marble chips and the dilute hydrochloric acid, when we use smaller marble chips into the reaction, it reacts much faster and quickly. When we use smaller marble chips, they react much faster and quickly. But when we use large marble chips, then what happens? It takes some time to react. Okay, so we can say that red color graph is much graph having much steeper gradient than the greener one. So by observing these two graphs, we can say that the rate of reaction is inversely proportional to the surface area of marble chips. That means when we increase the surface area of the reactants, it decreases the rate. Likewise, when we decrease the surface area of reactants, it increases the rate. Okay, that means they have inversely proportional relationship. Change in the concentrations of the reactants. When we increase the concentrations of the reactants, what happened to their rate? Yes, the reaction become faster. Increase in the concentration increases the number of particles within a fixed volume. Therefore, the particles are close together and collide more frequently. So, when they collide more frequently, there are more successful collision between particles every second. As you can see in this graph, rate is always higher under the high concentrations of the reactants. Here I will show you this reaction is happening under a low concentrations of reactants and this is under high concentrations of reactants. Likewise, when we increase the concentrations of the reactants, their rate will be increases. Okay, so we can conclude this phenomena as this: when the concentrations of reactants are higher, more particles collide successfully, it increases the rate of reaction. Understand? Okay, then we are going to learn the effect of concentrations of reactants on its rate experimentally. Okay, what is this experiment then? Investigating the effect of change in the concentrations of the acid on the rate of reaction between marble chips and the dilute hydrochloric acid. In this case, we are checking how concentrations of reactants affect to the rate. So, since we are checking the concentrations of reactants and their effects, we need to change the concentrations of dilute hydrochloric acid. Understand? Okay. So, what you have to do? You have to repeat the previous experiment that we have done between the same marble chips and the dilute hydrochloric acid, but in this case you have to change the concentrations of dilute hydrochloric acid. You have to make a series of dilute hydrochloric acid by changing their concentration. Understand? Okay. Then calculate the average rate during the first 30 seconds using the mass of carbon dioxide loss in the 30 seconds. Then you will get a graph like this. Here, if I am explaining this graph, then x-axis representing the rate of reaction and y-axis representing the rate of the reactions and x-axis that representing the concentrations of HCl, concentrations of the hydrochloric acid. Okay. So, you can, I think you can see here clearly, when we increase the concentrations of the hydrochloric acid, it also increase the rate. So, you can see some relationship between the concentrations of HCl with the rate of the reaction. Okay, then we can come up to a conclusion as the rate of reaction is directly proportional to the concentrations of the hydrochloric acid. It's directly proportional. That means when we increase the concentrations of HCl, it increases the rate as well. Okay. Then we are going to learn about the next factor. That means change in the temperature of the reaction, how it affects the rate. Okay. We know that reaction gets faster as the temperature is increases. That means when we increase in the temperature, all the ways reaction get faster. Okay. Why it happen, children? Do you know why it happen? Do anyone have idea? Okay. With the increase of the temperature, particles tend to move faster. Since they get in more energy from the temperature increase, they move in faster. So, when they move faster, they collide more frequently. When they collide more frequently, then it can lead to the successful collisions. When there are successful collision, it increases the rate of reaction. That's how the rate increases when we increase the temperature as well. Okay. So, when they collide, the energy which produced due to the increase of temperature apply to reach their activation energy. They only react, they only go until a successful collision if only they reach the activation energy. Understand? Okay. So, when we carrying out a reaction at a low temperature and the higher temperature, obviously you can identify that always rate is higher at the high temperature, because at the high temperature, that temperature giving more energy to the particles to exceed their activation energy. When they exceed their activation energy, they move faster and collide more frequently and then increase the rate. Understand? Okay. Here I have given you a picture which explain that previous phenomena further. Okay. So, here you can see this pink color and the green color particles. When they are in a low temperature, the particles also have less energy. That means they less frequently collide each other and less successful collision. They having some successful collisions, but they are not that much higher. Okay, so their rate is also low. But when we go to higher temperature, when these particles react in the higher temperature, the particles also have high energy. When they have high energy, that means when they have high kinetic energy, they collide more frequently and giving more and more successful collisions. So, these successful collision they tends to increase the rate of reaction. Understand? That's how it increases the rate of reaction with the temperature. So we can conclude it as when the rate of reaction is the rate of reaction is directly proportional to the temperature in the reaction medium. That means when we increase the temperature, the rate of reactions also increases. That means they have in a directly proportional relationship. Understand? Now we are going to find out how changes of pressure will affect of the rate of reaction. Change in the pressure of the reaction. This only affect on the rate of reactions which gaseous molecules participates. We don't consider here, don't consider about the reactions which solid and liquid molecules are participating. Okay. So as you can see in this picture, when the medium having fewer number of gaseous molecules having enough spaces to move around. Okay, just check the first picture. In there, they having enough spaces to move around. So there are little chances of the successful collisions. When they are having a little chance of successful collisions, there is a low rate of reaction. But when it's increasing the pressure of this medium, it automatically decreases the volume. As you can see in the second picture. Okay, it automatically decreases the volume. Now particles having limited spaces to move in and move likely to, they are more likely to collide. When they have limited spaces, they are more likely to collide. They don't have now enough spaces. They have limited spaces now. So they more likely to collide. So then we can see that they are colliding more frequently and it can lead to the successful collisions eventually. So that's how they increase the rate of reaction. When we increase the pressure, it increases the rate of reactions by increasing their successful collisions. Understand? Here we are going to learn about the effect of catalyst on the rate of reaction. We know catalysts are substances that speed up chemical reactions without wasting itself. Okay, they are speeding up chemical reaction. Okay, they are accelerating the rate of reactions. So normally these catalysts, they remain unchanged at the end of reactions, and different reaction needs different catalysts. Okay. So here just assume at the beginning of reaction, if we introduce a catalyst at the beginning of the reaction, here this green color one, 2 particles. Okay. What it doing? It increase the rate of reaction. That means it accelerate the rate of reaction and remain unchanged at the end. Okay. So that's the nature of the catalyst. Okay children, do anyone know about the biological catalyst? I think you have learned this in the human biology, right? About the biological catalysts. Do anyone have idea? Just recall your memory about the biological catalysts. Yes, enzymes are known as the biological catalyst. We have learned so many enzymes which accelerate in our metabolism and we accelerate in the rate of reactions which happen at our body. Okay, some enzymes are accelerating the digestive reaction. Likewise, okay, we know there are so many enzymes in our body. If we take some example, amylase, what it's doing? It breaks down the starch, and protease, it breaks down the proteins. Okay, whether those are decomposition or breakdown reactions, those enzymes, what they doing? They speed up those breakdown reactions. As well as lipase is the catalyst. Lipase is the enzyme which break down the lipids into smaller molecules. Okay, likewise enzymes are known as the biological catalyst. Then MnO2, that means manganese dioxide, lead dioxide, that means PbO2, can catalyze the decompositions of the hydrogen peroxide, which is H2O2. Okay, that we are using manganese dioxide and lead dioxide as the catalyst which helps to decompose hydrogen peroxide. Okay, let's look at on the reaction. This hydrogen peroxide is breaking down onto water and oxygen when it is present manganese dioxide or lead dioxide. Okay, this can happen without manganese dioxide and lead dioxide also. But when it is present, these two chemicals, it accelerating the rate of reaction. It speed up this reaction. That's what catalysts are. They speed up the reaction. Understand? Okay, now we are at the end of this lesson. So I believe that you got a really good understanding about the rate of reactions and the factors which affected to the rate of reaction. Now we are in the summary. So what we have learned in there? Let's recall our memory. We have learned the rate of reaction is the speed at which the amount of reactants decreases or the amount of products increases. We have learned about the rate of reactions and its definition in this lesson. And we have learned that successful collisions which are equal or exceeding activation energy always leading to a reactions. Okay, and and also we have learned more about the rate of reaction. Then in there, rate of reactions can depend on several factors. We have learned that it can affect with the surface area of the reactants, concentrations of the reactants, temperature, pressure and the presence of the catalyst. Those are the factors which affect to the rate of the reaction. At the end of this lesson, we have learned that catalysts are the chemical substances which speed up reactions without wasting up. Okay children? Here I have included some exercises and the references links. Please go through these exercises and the references in order to brighten up your knowledge regarding the rate of reaction. So, this is the end of this presentation. Thank you for listening. Goodbye.